All right, so this is chapter 1, section 2 on graphs and lines. All right, so in this section, we're going to examine one of the most basic geometric figures, which is a line. Now, when the term line is used, we mean a straight line. We don't mean a squiggly line or anything like that. We mean a straight line. Now, this section is going to outline how to recognize and graph a line and how to use the information concerning a line to find its equation. Now, examining graphs of equations often reveals additional insights into the nature of the equation solutions. Now, the Cartesian or rectangular coordinate system consists of two real number lines, one horizontal and one vertical, that intersect at their origins. Now, the two number lines are called the horizontal axis and the vertical axis, and together they are referred to as the coordinate axes. Now, the horizontal axis is usually referred to as the x-axis, and the vertical axis is the y-axis. Now, the coordinate axes divide the planes into four parts called quadrants, which are numbered counterclockwise using Roman numerals from 1 to 4, and it starts with the upper right quadrant. So, if we look over here, what we're talking about with quadrants, this would be 1, this would be 2, this would be 3, this would be 4. Here's our horizontal axis, which is the x-axis, our vertical axis, which is the y-axis. Here's our origin, which would be 0, 0. And then any of these points in here, it's going to be x comma y. So if x is a and y is b, that's going to be this point here. So, a is probably about 7.5, and b is also about 7.5. Now, if we had a negative 5, 5, we're going to first go x left 5, and then we're going to go up 5. And if we had the point 10, negative 10, we're going to first go 10 to the right and then 10 down, and that will give us our 10, negative 10 point. So that's kind of how these work for the Cartesian coordinate systems. Now, the fundamental theorem of analytical geometry is there's a one-to-one correspondence between the points in a plane and the elements in the set of all ordered pairs of real numbers. Each point in the Cartesian coordinate system corresponds to exactly one ordered pair of real numbers. And each ordered pair of real numbers corresponds to exactly one point in the Cartesian coordinate system. Now, what if we want to have a graph of ax plus by is equal to c? All right, so you've probably seen before in other classes, we have an equation of line ax plus b is equal to 0. And here a cannot be equal to 0, or basically you just have b is equal to 0, and so it's nothing, it's not going to be a line. And it's going to be a linear equation in one variable. So the one variable is x. Now we consider linear equations in two variables, which is the x and the y. So linear equation in two variables is an equation that can be written in the standard form ax plus by equals c, where a, b, and c are constants, and a and b are both not equal to 0, and the x and y are the variables that we can plot on the x and y axes. Now, the solutions to the equations in two variables, say we have the standard form of a linear equation, 2x minus 3y equals 6. A solution to that in two variables is an ordered pair of numbers that, when substituted into the equation, results in a true statement. And so look at the ordered pairs 3, 0 and 9, 4, are solutions to the equation. So when those values are the two ordered pairs are substituted into this equation, the result's true. So if we have x is 3, so it'd be 2 times 3 is 6. And then if y is 0, that's going to be a 0, so 6 equals 6. That's true. Now, what if we plug in 9, 4? Well, 2 times 9 is going to be 18. 3 times 4 is 12. 18 minus 12 is 6. So both of those are true statements, and so they're both solutions to that equation. Now, let's use a different one that's not a solution, 0, 2. So if we plug in 0 for x, that's going to give us 0. If we plug in 2 for y, that's going to be a negative 6. Well, negative 6 does not equal 6, and therefore it's not a solution to that equation because it's not a true statement. But if we plug in a negative 2 instead of a positive 2, that's going to be a negative 3 times a negative 2, which is positive 6. And that's still 0, so 6 equals 6, and so that's going to be a solution. So that's kind of how we're going to look at solutions to the equations in two variables. Now, theorem 1 says a graph of a linear equation in two variables in the form ax plus by equals c, again, a and b are not both equal to 0, is a line, and any line in a Cartesian coordinate system is a graph of an equation of this form. Now, observations. If A is not equal to 0 and B is not equal to 0, then the standard form linear equation of AX plus BY equals C can be written as Y equals negative A over BX plus C over B. And that's equal to basically our MX plus B. So M has to be the negative A over B, and B has to be C over B. So what we're basically doing is solving this equation for Y. So first we subtract the AX over here, and so that would be a minus AX plus C. And then we're going to divide by B. And so when we do that, we end up with this. And so that is our slope, and that's going to be our intercept. So if A is equal to 0 and B is not 0, then the standard form of the linear equation is going to be Y equals C over B, and its graph is a horizontal line. So that's when this one, the A is equal to 0, and this is not equal to 0, because we can't have B equal to 0 because you can't divide by 0. And so if we're making this equal to 0, then basically we just get Y equals C over B, and that's some horizontal line wherever it lands. Now, if A is not equal to 0 and B is equal to 0, then the standard form of the equation can be written as C over A, and its graph is a vertical line, okay? And so what happens here is we're having a vertical line. It's going to be, the vertical line has no slope, and so it's undefined. You can't divide by B. And so what we're doing is we're solving for X instead of solving for Y. And that ends up giving us C over A as our thing. And so what happens here is when we have our B is equal to 0, this goes away. We solve this for X. And so we divide by the A and we get C over A. All right, so if we want to graph a linear equation in two variables, basically we're going to basically just plot 2 points in the solution set and use a straight edge to draw the line through these 2 points. And that's going to be the easiest thing. Any 2 points make a line. Now, they have to make be the right 2 points, otherwise you're not going to make the right line. And so that's kind of the key here. And so the points where the line crosses the axes are often the easiest points to find, since these allow for substitution of X equals 0 and or Y equals 0. So if we plug in X equals 0, we'll get Y equals something. If we plug in Y equals 0, we'll get X equals something. And those will give us 2 points on the graph. And that's going to be the easiest two usually, because when you plug in 0, that part of the equation falls out and all that's left is the other. And when you plug in that for 0, half the equation falls out and you just have what's left over for X. Now, the point corresponding to X equals 0 is a point on the Y-axis and is called the Y-intercept. And the point corresponding to Y equals 0 is a point on the X-axis and is called the X-intercept. Now, it's a good idea to plot a third point, because you can, like I said, you can make a mistake on one of those 2 points, get a line, and you say, oh, that's a perfect line. Yeah, it's a perfectly straight line, but it might not be the right one. And so you always want to do that third point to check your work. So if that third point you do falls on that line, then you're good to go. If it doesn't, then probably one of your 2 points is incorrect, and you should try again and see if there's any calculations you've done wrong at that point in time. All right, so let's stop here and we'll go do some examples.